Hi, I'm Elena.
I'm Kylie.
I'm Tyler.
And we also have Jasmine, but she's not here. So, you know how whenever you sit down in sunny areas instead of shady areas so your butt doesn't get wet? Well, we kind of wanted to figure out why behind that. So our research question is, how does the canopy cover affect the levels of soil pH and soil moisture in areas exposed to precipitation, and why? And our hypothesis was that if the area has more canopy cover, the soil will have a higher pH and moisture level compared to the areas with less canopy cover, because it'll take longer for the water to evaporate, creating a moist environment, which also affects the pH level.
Okay, so in our investigation plan, we decided to choose 4 sites, and we also used some sites from other groups, so that's why our data is a little more than 4. But our sites had 2 with little to no canopy cover, and then 2 that had moderate to high canopy cover, so they were either covered or not. And then we measured those canopy covers with a percentage. We measured the moisture of the soil in each of those sites after a rainfall. We took samples from all of our sites for pH. We measured the pH from each site, and then we decided to compare the pH, the soil moisture, and the canopy cover to see if there were any relations between them. And so all of our sites are marked on this little map. It may be hard to see because it's small. So, but we have site 1 is south of the UT Tyler Longview campus, about 65 centimeters, and it's a mowed area exposed to sun. Site 2 is southwest side, and it is 2 meters and 18 centimeters away from a water drain. It's a mowed grassy area exposed to sun. The east side of the UT Tyler Longview campus is our 3rd, and it's shady mowed area exposed to the sun at parts of the day. And then site 4 is on the southeast side of the UT Tyler Longview campus in an unmowed shady forested area. And then we have our additional information, which is just the basics of pH. 0 acidic, 7 neutral, above 7 basic, and then if it's acidic, and then it has free hydrogen ions. If it's basic, then it has hydroxyl ions.
So we collected all the data, and we collected pH level, canopy, and soil moisture from all of our groups in our classroom. And here's a list of the table.
And we also made a histogram chart right here that shows the relationship between the canopy cover and the soil moisture. And you can see with the most canopy cover has the highest soil moisture.
So our data analysis, our histogram shows that the soil with 80 to 100% canopy has the greatest soil moisture, and 50 to 60% has the second greatest moisture level. 0 to 9 has the second to lowest moisture level. So after collecting and analyzing the data, we realized that soil moisture and canopy have a correlation. Typically, as canopy cover increases, soil moisture increases as well. So for our conclusion, we have discovered that the more canopy cover over a particular site will result in an increase in soil moisture. In turn, a moderate amount of canopy cover will result in a higher pH level. This is because canopy cover blocks rainfall from falling onto the ground. However, areas with more canopy cover will hold moisture longer from lack of sun. There's also a connection between moisture and pH. The higher the moisture level, the higher the pH level, which means the area is more basic. Our findings prove that our hypothesis was correct. Areas with more canopy cover do result in a higher pH and moisture level. This is the reason why you sit in sunny places, so your butt does not get wet. We had some limitations and sources of errors for our conclusion. Pounding the tin can into the ground to collect the soil dented the can, but to limit the limitation, we remeasured the volume of the dented cans and used that data to continue our investigation. We also have our bibliography for soil pH, soil moisture, and soil density, even though we didn't use soil density.